Hello everyone, welcome back to Emoji Comes YouTube channel. Hope you're all doing well today. Right. I think this should be our last class on the solo growth model, and that's for now. So I don't know, something else might come up in the future, and we have to record more classes on the solo growth model. All right. I think there's been something that I've not been mentioning up to this particular moment, which is the fact that the solo growth model is the simplest version of the neoclassical growth model. So I think in some books, maybe in some exams or maybe some tests or whatever, you might be asked to differentiate between neoclassical growth model and the endogenous growth model. You understand? So just know, so anywhere you see neoclassical growth model, I don't really know what to say. So just have it at the back of your mind that it's kind of referring to solo growth model and other neoclassical growth models. Okay. So far so good. There have been highlights from what we've been learning. So number one, what are the highlights of the solo growth model (SGM)? Number one, if countries have the same population growth rate, saving rate, and capital depreciation rate, they would have the same steady states and converge. All right. So I don't think this is something that is difficult from what we've done so far. From sketching different graphs and whatever. So if there are two or more countries, that happen to have the same population growth rate, the same saving rate, same depreciation rate. So they will all reach a steady state. So like they are going to reach the same steady state. So and then stay there. All right. So that is telling? That's what is meant by convergence. All right. So different countries will eventually converge. Like African countries, for example. So maybe Nigeria, Ghana, and Sierra Leone. If these three countries happen to have the same population growth rate, they happen to have the same saving rate, they happen to have the same depreciation, rate. So what that means is that they are all going to grow up to a particular point and stay there, so they would converge. And alternatively, so if countries have the similar saving rates and population growth rate and whatever, they are not going to converge. They are going to diverge. So in that sense, we say that we have divergence. So countries are not going to converge in that essence. So an example might be Nigeria and let's say the United Kingdom. Okay, so these two countries do not are likely one is developed, one is not, or one is developing. Okay, one is like something like very developed. So UK is like very developed. Nigeria is still developing. Okay, so in this particular instance, the saving rates, the depreciation rate, the population growth rates, they are likely not going to be the same thing at all. So countries like that, not much as that's what is happening. All right, so we would expect that okay, there should be a divergence since these three things are not, taking place. But if it happens that Nigeria now begins to follow the pattern of the United States and of the United Kingdom, for example, and begins to save as much as the United States is saving, and then invest too. You understand? So you save, invest as much as the United States is investing, control its population growth rate as much as the United States is controlling its own. So that means, at the end of the day, United States might just be faster than Nigeria because it is, ahead. Do you understand? But then it will get to a point where Nigeria is going to catch up with the United States, and I think that is what is probably used to explain why China is now close to states like the US, and other things like that. So initially it wasn't like that, but then now China is one of the world's economic powers. Okay, or maybe economic superpowers. I don't even know if that's the way to put it. But China is everywhere now. China is very strong. Do you understand? So like we now say, okay, China and the US are reaching a point where they are going to converge. You understand? Or maybe they've converged already or something like that. Okay. So just take that. Just take that like that. Now along the convergence path, poorer countries grow faster. Okay. And the reason for this is that for a country like Nigeria that's still developing, and a country like the United States or Malaysia that is developed, you know, um, Malaysia is already like very developed. So if you try to increase your capital per worker in Malaysia and then try to increase capital per worker in Nigeria, okay, you would kind of discover that the marginal product, of the additional capital per worker in Nigeria would likely be higher than that of Malaysia. What that is trying to tell us is that the Nigeria's productivity, okay, given the same amount of technology, is going to be higher than that of Malaysia. Why? So I try to explain this, using two children. So one is malnourished, and the other one is, healthy, a healthy child. So if you give a healthy child a healthy food, like a healthy food, so the difference between what that healthy food would do to the child and how the child had been doing initially will be very minute, like very small. But if you begin to give the same healthy food to a malnourished child, before you know it, the growth and development that happens to that child is very rapid. Do you understand? So like that is what is happening. Okay, so you see developing countries as the malnourished, kid. You understand the malnourished children or the malnourished child. So when you give this guy, when you begin to give this guy the kind of technology that you are giving to the healthy economy, all right, you see that it has a greater effect on the developing child. So that is why, um, realistically speaking or empirically speaking, developing countries are poised to have a higher growth rate if they are serious. Okay, a higher growth rate than developed countries. It's not as if developed countries are not are not doing well. It's not as if they are not even doing better than developing countries, but because they've reached a very high stage of development in their economy, that something more. You understand? We just give them a less proportionate out compared to an economy like Nigeria's. Okay, so that's just what the point is trying to explain. That along the convergence path, there are poorer countries growing faster than richer countries. So US may have gone first, but if Nigeria wants to be serious, you understand, and it's fed the same thing that the US economy is feeding its economy, right? So Nigeria will begin to like grow kind of very fast. So to grow very, very fast. What took the United States maybe 100 years to achieve, Nigeria might achieve it in like maybe 21 years. You understand? Okay. Now, number three, when the savings rates are different, growth is not always higher in a country with low capital, stock. So when the savings rates are different, so here you have two countries, let's say Nigeria and Ghana. Okay, they both have low capital worker ratio. You understand? Because if Ghana happens to be a serious country that ensures that its country saves more, you understand, and Nigeria is a country where people just kind of do what they like, and stuff like that. So you see that there's going to be more growth. All right, there's going to be more growth, a better standard of living in Ghana, that happens to be a serious country economically than Nigeria. So it's not always the case that okay because you have um, a low because you are a malnourished child now, you are a malnourished economy, and then saving and investment begins to take place. That you jump like that. So you have to be serious about what you want. Okay, you have to be dedicated to the long run growth and standard of living of your citizens. So like you can't just grow, because uh, you know how do I even put it now? So like you have to be focused. So that's what I'm saying. So if there are two countries, there was a time when maybe Malaysia wasn't really that, there are stories of it that Malaysians came to Nigeria to take palm kernel, and now they are one of the biggest producers of the palm oil in the whole world, and if not the biggest, then the top two, like right now, behind in Indonesia. So you have Indonesia, Malaysia, and where is Nigeria? Nigeria has gone further backward. Okay, so now what has happened? So one country was serious than the other one, so overtaking is allowed. So that's what this is trying to say. Overtaking is allowed. So it doesn't mean that because okay, you're starting from a very poor state, as you and other countries, so if I'm more focused than you are, if you are more focused than I am, so the results should be different. Okay, so that's what I can say about that explaining convergence, divergence, in addition to whatever I've read from the Solow model. Now we have a calculation example. So an economy has, we've done the theory, we've drawn graphs, whatever. So an economy has the power production function where y is 3kt raised by 0.5. The depreciation rate is 0.1, and the population growth rate is 0.05. Saving, okay, that's national saving as a function of national income is 0.3 YT. So where S is whatever. Now A, what are the steady state values of capital labor ratio, output per worker ratio, and consumption per worker? So what's now what's the first thing that we are going to do? Let's try to solve the problem. So we know that at steady state, okay, service per worker, that's a S, I think I call it S, this YT is equal to N plus D. I call this IT. But we are equilibrium anyway, so we can just suspend the whole T. Alright, so but here we're given 0.3, which is like the national saving. Okay, the national saving S is 0.3 YT. So all we just have to do is divide this through by the population by number of workers. So when we divide this by number of workers, okay, so this guy gives us what is here. We have S I I T. Uh, no, that's again. We have savings. Will then be equal to 0.3 YT. So we have this condition which is what we have at equilibrium. So 0.3 YT is equal to N population growth rate 0.05 plus 0.1, 0.05 plus 0.1, then K, well, no, this is not I, sorry, it's supposed to be KT. So KT, I'm going to drop the T down whatever now. Now YT on its own has been given to be 3 KT raised by this. So now, so we have 0.3 into brackets 3 KT raised by 0.5 equals 0.15 KT. Okay, it is capital power. So this guy is 0.9 KT raised by 0.5 equals 0.15 KT. So what we just do is we divide both sides by 0.9. So we have KT raised by 0.5 plus 0.15 divided by 0.9. So that's going to give us 0.17, 0.17 KT. So we divide through by KT. So this is KT, 0.5 from your indices minus 1 plus 0.17. So this is KT square minus 0.5 plus 0.17. So you can multiply the powers by minus 2. If you multiply the powers by minus 2, so you have KT alone plus to 0.17 raised to power minus 2. The power here initially was 1. 1 times minus 2. Alright, so here KT can be written as 1 divided by 0.17 square. And that's going to give us 34.6. 34.6. Okay, so that's that about that. So the capital per worker, the steady state capital per worker is 34.6. So the next thing says that we should calculate um, output per worker, consumption per worker. So output per worker, okay. So we have YT equals 3 KT, okay, given YT equals 3 KT raised by 0.5. Right. So and here they have KT as this. So YT equals 3 into brackets 34.6 raised by 0.5. These are the roots of 34.6. So the root of 34.6 then multiplied by 3 is 17.64. 17.64. Alright, so that's the output. Now the next is consumption per worker. So for us to get consumption per worker, consumption per worker CT is equal to YT minus investment. Alright, so we need to know investment. So IT equals to 1, that's where is it? This plus 0.15 KT, into brackets. KT is 34.6. Alright, so 0.15 multiplied by 34.6. Let me write it. Okay, so 5.19. 5.19. So consumption per worker equals 17.64 minus 5.19. Okay, 17.64 minus 5.19. So I think, okay, 9.6. Okay, 17.64 minus 1. Okay, if we do 17.6 minus 5.2, then just 17.64 minus 5.19. Okay, 14 minus 5, 14 minus 9 is 5, 5 minus 1 is 4, 7 is 12.45. So the consumption should be 12.45. Okay, so that's that about the first part, of the calculation. Initially, what did I even do? I did, okay, I don't think I calculated consumption here initially. Anyway, it's all good. And so we then move into the next question. Next question says that you should repeat A for a saving rate of 0.4. So now our saving rate is no longer 0.3. So repeat that for a saving rate of 0.4. Other things remaining the same. Alright, so now S, um, so this S over L now is going to be 0.4 the YT over L. So that is um, this guy S is equal to 0.4 IT. So we just repeat the same thing. So at steady state, 0.4 YT equals to 0.15 KT, and then this guy is 0.3 KT raised to 0.5 equals 0.15 KT. This time, no, this is 3, not 0.3. This time, this is 1.2 KT raised to 0.5 plus 0.15 KT. So by the time you, let me just do it. KT raised to 0.5 plus 0.15 divided by 1.2, 0.125 is 0.125 KT. So KT now be 0.125 raised to power minus 2. And the answer 0.125 raised to power minus 2 is 64. Okay, so you can see that theoretically speaking, this is correct. Now, when saving increased from 0.4 of its income now to from 0.3 of its income, that's 30% of its income now to 40% of its income, we can see that the capital per worker also increased. Do you understand? The steady state capital per worker also increased, which is a line which what we've been learning since. Alright, so then the next thing is for us to calculate YT. I haven't calculated KT, so YT. So YT is now going to be 3 into bracket 64 square 0.5. Now this is root 64 anyway. Alright, so root 64 is 8. 8 multiplied by 3 is 24. So you can see initially YT was 17.64, now it's 24. How about consumption? So but before that we have to get investment. This 0.15 KT, which is 64. Okay, 0.15 multiplied by 64, that's 9.6. 9.6. So now the consumption per worker is 24 minus 9.6, and that gives us 14.4. 14.4. So you can see all of them are higher. Standard of living is better now, 14.4. Investment that was 5.19, so more is being invested into, and then outputs that was 17.64. So also increase. So if you look at it, The growth rates in output is the growth of output now, not the growth rate, is about 6 point, almost 7, maybe like 6.36, like 6.36 or something like that. So out of that 6.36, more went to investment than to increasing standard of living. So that this will tell us that now more has to be spent in the creation of capital stock for the additional, not additional workers, for each worker. And investment is still test. You have to maintain the old stock, and you also have to like create new stock. So more goes into investment than into consumption. But whatever happens, you can see that the standard of living has improved. So now, if you were to sketch a graph, that's not part of the question, but I think I like graphs. Okay, it's kind of make things, it put things in perspective. So now let's see if it's in line with all that we've been learning. So we have this, we have this. So this is our KT. This is 0. So on this graph, we'll be plotting IT, we'll be plotting YT, and we're plotting ST. So this is K. So this is IT equals to IT equals to 0.15 KT. Okay, 0.15 KT. Then we have the saving. Initial saving that was um 0.4, 0. When we express in terms of KT, okay, saving is 0. Almost 5 like this, so that's 1.28 raised by 0.5. Or do I need to, let me just use 0.4 YT, or why not put here 0. Was initially it was 0.3. Okay, initially we have 0.9 KT raised by 0.5. Right, and then the initial output, something like this. So where y happens to be 0.3, no, 3 KT raised by 0.5. Alright, so the initial value of KT at this point happens to be 34.6. 34.6. So we trace where this is happening at the okay, let's just take that. So if you decide to bring it up, so the output at that point, what was the output at that point? Initial output 17.64. So here it was 17.64. Okay, I don't know. Was there something else that I brought out? Saving equals investment. Investment is 5.19. So at this point, 5.19. So that was the initial point. So the consumption AB happens to be AB. Alright. So that was the initial stuff. But now that the savings rate has increased, so we have, this is the initial savings. So we have something like this. So this guy is 1.2 KT plus 0.5. So if we now look at it, this is 64. we trace it to the new outputs. Okay, let's just manage that. So which happens to be 24. The new output is it? Yeah, the new output is 24. Okay. Then consumption is okay, this guy here. This is where we have the new equilibrium. So at that point, investment happens to be 9.6. Okay, so our new consumption is now C, and CD. Okay, so I think that's all about the graph. 2417. So that's all about the graph. All right. And with that, you can see that the theory that we've learned is in line with this calculation. This calculation that we have here is in line with whatever theory that we've been learning, all this while about the solo group. So whenever you have problems like this, that's how to approach them. So repeating C and D is going to be one of your assignments. So there is still another, assignment. So just repeat C and D, and get whatever it is that you want to get. So I'll write second assignment on the board. So here comes the second assignment. Consider a closed economy in which the population grows at 1% per year. The household power function is given as 6 root k. Capital depreciate at 14% annually. A. Households consume 90% of income. What are the steady states values of K, Y, C, and I? Now the country wants to raise its steady state values to of the country wants to raise its steady state values of Y. What steady state value of K is needed to double the steady state value of Y? And what fraction of income would households have to save to achieve that? Okay, so that's it. So with that, we come to the end of the Solow growth model. So in our next class, we'll be talking about the endogenous growth model. Thank you very much for watching. Meet you there.